Let's solve 2x to the fourth minus 64 equals 0 and 2x to the fourth minus 64 is greater than 0. We'll start with the equation. Since there's only one term involving x, we're going to work to isolate the x. First, we'll add the 64 to the other side, so we get 2x to the fourth is equal to 64. Then we'll divide both sides by 2, so x to the fourth is equal to 32. Now we're going to take the fourth root of both sides of the equation. But since we're taking an even root of both sides, we're going to get out plus or minus. So we're going to have the fourth root of x to the fourth is equal to plus or minus the fourth root of 32. So now on the left, the fourth root of x to the fourth is just x, because what's happening is this is x to the fourth to the 1/4, and 4 times 1/4 is 1, so we have just an x on the left equals plus or minus the fourth root of 16 times 2. So I'm writing it like this because the fourth root of 16 is just 2, so we can write our final answers as x equals plus or minus 2 times the fourth root of 2. Now let's solve 2x to the fourth minus 64 is greater than 0. It might be tempting to attempt to solve this problem using a similar method as solving the equation, where we try to isolate the x, but unfortunately it's not going to work in that same way, and that's because this is an even degree polynomial. So the process that we have to take to solve this inequality is to find the zeros, which we already did over here, and to create a number line and do a sign analysis. So I'm going to go ahead and show what that looks like. Here is my number line of the domain, negative infinity to infinity, and I went ahead and plotted my zeros that we found from solving the equation. So I have positive the fourth root of 32 and negative the fourth root of 32. And that creates 3 separate intervals. So 1, 2, 3. And I want to test what happens over each interval. So we're going to pick a test value and see whether plugging in that value makes the function positive, which is what we want, greater than 0, or negative, which is what we don't want. So we have to pick some test points in here, and between a negative and a positive value, there's always 0. So in the middle interval, I'm going to pick 0. And then I'm going to have to pick some values over here. Well, if we had a calculator, we can approximate the fourth root of 32. But let's pretend for a second like we don't. We know that a number that's bigger than the fourth root of 32 is the fourth root of 81. So why am I picking that number? Because that's actually a really nice number. The fourth root of 81 is 3, because 3 to the fourth power is 81. So I can pick 3 and say 3 is definitely over here in this interval. And that means over here, negative 3 is a value in this interval. So just trying to develop some number sense in case we don't have a calculator. And we take these test values and we substitute them into the function and see what comes out, a positive or a negative. And that's representative of what's happening over each interval. So here, if I plug in negative 3 into x to the fourth, so I'm going to have 2 times negative 3 to the fourth minus 64. Well, as I said, 3 to the fourth is 81. This is still going to be positive, so it's going to be 2 times 81 minus 64. And I don't have to find the exact value. I just have to know whether this is positive or negative. And this is definitely bigger than 64, so we're going to have a positive value. If I plug in 0, 2 times 0 to the fourth, well, that's just 0. Minus 64, that is a negative value. And then finally, if we plug in 3, we're pretty much going to get the same quantity as the first interval we tested. 2 times 3 to the fourth minus 64, that's 2 times 81 again, minus 64, which is a positive. So we don't want this middle interval where the outputs were negative. We wanted to know where I'm greater than 0, which means positive intervals. So I'm going to take this interval here from negative infinity to negative the fourth root of 32, and then the fourth root of 32 to infinity. So we'll express that in interval notation as all x values in negative infinity to, I'm going to write the simplified answer again, negative 2 the 4th root of 2, open parentheses, and then 2 the 4th root of 2 to infinity. So we don't want to include those values because that's where I was equal to 0, and I want to know where I'm greater than 0. So sometimes on the sign analysis, we can put a little z above each of these values to remind myself that they are in fact zeros and I want where I'm greater than 0. Now we want to solve x to the 4th plus 1 equals 0, x to the 4th plus 1 is greater than 0, and x to the 4th plus 1 is less than 0. We can actually solve this equation and these inequalities without any work if we just have a little bit of number sense and understand what we're doing when we're solving equations. We're looking for all x values that make the statement true. So for this equation here, if we take any x value and we think about raising it to the 4th power and then adding 1 to that number, is there any way that can ever equal 0? Well, the answer is no. So if the x value you chose was 0, 0 to the 4th is 0, 0 plus 1 is 1, which cannot equal 0. And if you chose any other number, when you raise that number to the 4th power, you're going to get a positive quantity. Even if you take a really big negative number, when you raise that to an even power, you're still going to get a positive number, plus 1, that can never equal 0. So this equation has no real number solutions, and that's what we're in search of, real number solutions. So here, there is no solution, which we can indicate as the empty set or a 0 with a line through it. Now with that same type of reasoning, let's look at this inequality. I want all x values that solve x to the 4th plus 1 is greater than 0. Well, as we said, if we plug in 0, 0 to the 4th is 0 plus 1. That's always going to be greater than 0. It's 1. And if we take any other x value, raise it to the 4th power, that makes it positive, then you add 1, that's always going to be greater than 0. So the answer to this inequality is all real numbers. So all real numbers we can indicate as negative infinity to positive infinity, or sometimes you'll see as this bold-faced r. And finally, solve x to the 4th plus 1 is less than 0. So what x values can I substitute in to make this negative? Well, we just said that the outputs are always going to be greater than 0. So that means this inequality also has no solutions. So no solution, or again, the empty set. Now, if you didn't recognize this and you tried to proceed solving this equation, we would attempt to isolate x. So I'd get x to the 4th equals negative 1, and then I would try to take the 4th root of both sides, and I'd get plus or minus the 4th root of negative 1. And this is where you're going to come across an issue with finding a real number solution, because if you take an even root of a negative number, you're going to get out some imaginary values. So we would stop there and say no solution, there are no real solutions.